Assalamu alaikum. My dear students, our lesson today is integration by substitution. Today we will use the substitution method to make integrations for some functions. Our objective is we will use substitution for something we call it changing the variable. We rewrite functions in a form that we can integrate, or to simplify the integration itself. Our first example, we have integration of x plus 2 all power 5 with respect to x. Okay. To simplify this integration, we take x plus 2 to be a function differentiable function. It is u equal x plus 2. Okay. Differentiating both sides with respect to x, we have derivative of u is u, derivative of x dx, derivative of 2 equals 0. So du equal dx. And now substituting x plus 2, okay, putting u instead of x plus 2 is the original function. We have integration of u power 5 du instead of dx, because u equal dx, and u power 5 instead of x plus 2 power 5. Now we have a simple function to integrate. Integration of u power 5 is u power 6 divided by 6 plus constant. Now we will inverse what we did before and put x plus 2 instead of x plus 2 instead of u. So the final form is x plus 2 all power 6 divided by 6 plus constant. Don't forget to substitute value for u back into the project. This step will be done last. Okay. This is the first example. Another example, we have integration of square root of 4x minus 1 dx. We will take u to equal 4x minus 1, the quantity under the square root. So u equal 4x minus 1. Differentiating u, du equal 4. For x, x is equal 4, negative 1, x is equal 0. So du equal 4 dx. Okay. Solving that for dx, we want dx as a function of du. So we will divide by 4, multiplying by quarter, both sides by quarter. So dx equal quarter du. Now substituting in the function. U power half multiplied by dx. Dx equal quarter du. Okay. We know quarter is a constant. Integrating u power half to be u power 3 halves divided by 3 halves or multiplied by 2 thirds. Okay. Simplifying, we have 6 u power 3 halves plus constant, and the last step, return u to be 4x minus 1 instead of u in the final step. Okay. From those two examples, we have a general form. This general form gives us, if we have a first degree function in x, first degree function in x in the form ax plus b. If it is raised to the power n, and we will want to integrate x with respect to x, okay, the integration will be same function, the power n plus 1 divided by n plus 1 multiplied by the coefficient of x. The coefficient of x here is the derivative of what between brackets and adding the constant. We have a very important condition here, which is n not equal negative 1. This case cannot be applied when n equal negative 1. Now I solve the previous example for x minus 1 dx using this rule. We can put it in the form 4x minus 1 whole power half dx. Okay, now applying this rule, it will be 4x minus 1 power half plus 1 power 3 halves divided by the new power, which is 3 over 2, multiplied by the coefficient of x, which is 4, plus constant. By simplifying, we will get the previous result. Okay. Now, we want to integrate 3x plus 5 whole power negative 9 dx. It is in the form, so we can write this integration directly. In the form ax plus b whole power n equal negative 9. So it will be 3x plus 5 whole power negative 9 plus 1 negative 8, that's divided by negative 8 multiplied by the coefficient of x, which is 3. Negative 1. 3 times negative 8 equal negative 24. Okay, 1 over negative 24 equal negative 1 over 24 will be the simplest form. And putting this in the denominator, it will be dx plus 5 over 8. This is the simplest form. Don't forget adding the constant. Okay, so now we have a general rule. If it is a first degree function, okay, raised to the power n, we will apply this rule. Another example. Integration of x plus 1 multiplied by x plus 3 all power 7 dx. It is not in the form we get now. How we can integrate it? Okay. X plus 1, we want to make it like x plus 3. So we will write it as x plus 3 minus 2. X plus 3 minus 2 is the same as x plus 1. This is multiplied by x plus 3 whole power 7 dx. Now, distributing this factor on this bracket. X plus 3 power 7 multiplied by x plus 3 will be x plus 3 power 8. X plus 3 power 7 multiplied by negative 2 will be negative 2 x plus 3 power 7 all with respect to x. Now we have two functions. Integration of x plus 3 power 8 dx minus 2 integration of x plus 3 power 7 dx. Now will be x plus 3 power 9 over 9 multiplied by the coefficient of x, which is 1, minus 2 times x plus 3 power 8 divided by 8 times 1, okay, plus constant. Here we have a constant, and here we have a constant. The sum or the difference of two constants will be a constant also. So we write only one constant. Okay. We have another example. Integration of x minus 1 multiplied by x power 2 minus 2x plus 1 dx. If we look between the second bracket, we will find a second degree equation, function, a second degree function in x. Okay. So we will go to factorize this function. So we have x minus 1 multiplied by this second degree function. We can factorize in the form x minus 1 over 2. Now we have the same basis. Adding the bars, we get x minus 1 power 3 dx. Its integration will be x minus 1 power 4 over 4 multiplied by coefficient of x, which is 1. So we can write it like that. Quarter x minus 1 power 4 plus constant. Okay. Now we have another square root of x minus 3 multiplied by x minus 3 power 4. X minus 3 and the square root will be x minus 3 power half multiplied by x minus 3 power 4 or dx. It will be x minus 3 power quarter plus half will be 9 over 2. By adding 1 to the power, it will be x minus 3 whole power 11 over 2 divided by 11 over 2 multiplied by coefficient of x, which is 1, plus the constant. Okay. Another example. Now we have square root of 1 plus x power 2 multiplied by 2x dx. If we look under the square root, we will find a second degree equation, a second degree function, and we can't factorize this expression. We can't factorize it. What we will do? Okay. Putting u equal 1 plus x squared and differentiating both sides, we get du equal 0 plus 2x dx. So du equal 2x dx. Solving that for dx. So dx will be du multiplied by 2x. Dx equal du, divided by 2x. Okay. Substitution, by substitution here, u power half, and instead of du, instead of 2x dx, okay, we will put du by 2x. Okay. Or we can write it like that. U power half, okay, times 2x dx sorry, times 2x, and instead of the x, put du by 2x. Now 2x will be cancelled and it will be in the form u bar half du, this form. Okay, by integration, u bar half will be u power 3 halves divided by 3 halves or multiplied by 2/3 plus the constant and resubstitution. By doing resubstitution, cancel u and put 1 plus x squared instead of u. Now we are going to a general form for this example. If we have u of x function, a differentiable function of x raised to the power n multiplied by its first derivative with respect to x. Okay, so this integration will be u of x power n plus 1 divided by n plus 1 plus the constant. I want to apply this rule for the previous example. The previous example was square root of 1 plus x squared times 2x dx. Look here. If you have u of x equal 1 plus x squared, x derivative u dash of x will be 2x. 2x dx. So we have u of x, u dash of x, and the integration with respect to x. So the rule is u of x or n plus 1 divided by n plus 1 plus constant. Okay. Applying this rule to another example, we have x power 2 minus 3x plus 5 whole power -7. This function is a second degree function in x, and it is differentiable because it is a polynomial. Okay, and its derivative is found here. So putting u of x equal x squared minus 3x plus 5, x derivative u dash of x, which is 2x minus 3. So we can apply the form directly. X power 2 minus 3x plus 5 whole power n plus 1, -7 plus 1 will be -6, divided by -6, then u power plus a constant. Okay. Another example. Integration of 3x power 2 minus 2x plus 1 all power 11 times 3x minus 1. If we take u of x to be 3x power 2 minus 2x plus 1, so x derivative u dash of x will be 6x minus 2. This function, not 6x minus 2. Okay, it is 3x minus 1. We can make it 3x minus 2 simply by multiplying by 2. So we will put in the form 3x power 2 minus 2x plus 1 all power 11 times 6x minus 2 divided by 2 all dx. 6x minus 2 divided by 2, it is 3x minus 1. Now we have 2 in the denominator, so we will write it like that. Integration of 3x power 2 minus 2x plus 1 whole power 11 times 6x minus 2 all dx. Now we have u of x and we have u dash of x. So our integration will be half times the function u itself, 3x power 2 minus 2x plus 1, power 11 plus 1 power 12, all divided by 12 plus the constant. Okay. Now we have x times 4x power 3 minus 3x power 2 plus 4 all power 5 multiplied by 2x minus 1. Taking u equal 4x power 3 minus 3x power 2 plus 4. So u dash will be 12 x power 2 minus 6x. Okay. Now we don't have this function, but we can find it like that. 4x power 3 minus 3x power 2 plus 4 all power 5 times. We will multiply x by 2x minus 1. X times 2x minus 1 will be 2x power 2 minus x. Okay. Look to this function and to u dash. 12x power 2 minus 6x is the same. Okay. After multiplying this function by 6. So we will write it in the form 12x power 2 minus 6x divided by 6. So we have u dash now 12x power 2 minus 6x divided by 6 all dx. 1 over 6 outside the integration. Now we have u and u dash. So we will write 4x power 3 minus 3x power 2 plus 4 power 5 plus 1 will be 6, all divided by 6 plus the constant. Now we have a general rule to find u. How can we choose the function u, which is a differentiable function with respect to x, to help us to do our integration? Okay. We choose u in 3 types. First, the quantity under a root or raised to a power. We took 4x minus 1 under the square root, and we took another function, another u, raised to some powers. So u is the quantity under the root or the quantity raised to power. The second case is the quantity in the denominator, and we will solve problems on it in the next sessions, inshallah. Third case, the exponent on e, and we will see that in the next session, inshallah. Thank you.